Hi, today we are going to continue to look at the box plots that we started with yesterday, but we're going to add something to these box plots. We're going to talk about outliers, and we talked about sometimes our data points affect what our results are. So we're going to look at what those data points are. And we're starting off with the EPA, and they are in charge of determining and reporting fuel economy ratings for different cars. So we're going to be looking at different kinds of cars here that you see in the chart. And this is from in 2008, the EPA changed the method of measuring a vehicle's fuel economy to try to give more accurate estimates that consider air temperature, air conditioner, and driver use of gas and brake pedals. The table below is going to show that gas mileage for a sample of 24 2012 midsize cars. All right, so we have this chart here. And what we need to do is we need to start off by entering this data into our calculator. So if you don't have your calculator out, go ahead and take it out. Press pause while you take it out. When you get your calculator out, remember to enter the data in. And what we're entering in are these values. Again, this is representing the gas mileage of the vehicles. So when we have our calculators out, what we're going to do is we're going to hit Stat. And we're going to enter these values in. And to enter the values in, we need to edit our list. So we hit Stat, and then we hit number 1. I've already entered my data in. So what I want you to do is I want you to press pause and enter all of that data in. And when you're ready, go ahead and press play again. All right, now that you're ready to go, let's go ahead and make some calculations. We want to first calculate the average and the range. Remember, average is just another word for the mean, and the range of gas mileage for the sample cars. So to get the average, we're back at our calculators. We're hitting Stat again. Remember, we do Stat Edit to put the data into our calculator. We arrow over to the right, and we want to do one variable stats. So we hit number 1. We have our data in list 1. Remember, we do not have a frequency table. All we do is have those 24 sample cars, so there should not be anything in the frequency list. So we go down to calculate, and the first number here, the X with the bar above it, that's going to be your average or your mean. So in this case, we have 29.08, and we have context here. Miles per gallon is the average for these 24 cars. Now the range is going to be found, remember that's from the lowest to the highest, which is going to go along with number 2. Number 2 is calculate the 5-number summary for those, which if we keep on going down with our one variable stats in our calculator, our minimum value is 18, our Q1 is 26, 28 for medium, or the median, Q3 is 31, and the max is 48. So we go ahead and fill those values in, 18, 26 for Q1, 28 for median, Q3 31, and the max of 48. So again, the range is the distance between the smallest value and the largest value. Our largest value being 48, so 48 minus the smallest value of 18. So 30 miles per gallon is the difference from the lowest miles per gallon to the highest. All right. All right, so we're going to take this data and we're going to make a box plot. And we learned how to make a box plot yesterday. And that range of values, we're going from 18 to 31. So I'm going to start at 15 And I'm going to, oops, not 18 to 31, 18 to 48. So I'm going to go from 15 all the way up to 50. Let's make this 20, 25, 30, 35, 40. Okay, that did not work. That's why I don't like doing it that way. So let's break it down. So we're going from 10 to 50, so we have a distance of 40. So we cut that in half. Then we cut that in half, and then that in half. So then that's going to be 20, 30, 40, 50, and then we cut each of those in half. Much better, much more evenly spaced data there. Now when we do our box plot, what I want you to do is I want you to leave space above it, because we're actually going to have two box plots on top of each other, because I want to show you a comparison of your data. So our minimum value here is 18. Our Q1 is 26. Median of 28. Q3 of 31. There's our box. And then our maximum value all the way over here at 48. So again, I'm going to leave room because I'm going to end up drawing another box plot on top of this. Oh, man. So that I can compare my values, 28, 31, and 48. What we're going to do is we're going to try to figure out, and we are going to have outliers today. So an outlier is used to describe the variability in a data set that has outliers, because unlike ranges, our IQR only looks at the middle values of the data. So remember, those outliers are these values that are so atypical for our data that they're skewing our data set. It's not within a reasonable range of values. And this IQR is going to help us figure out which values are just high and low versus which ones are too high or too far away from the rest of the data. The IQR is not impacted by outliers because it's only looking at the middle half of the data. So we have a very trustworthy tool here. To calculate the IQR, very simple, we do Q3 minus Q1. Because if you remember, we have 25% of our data here, 25% here, 25 here, and 25 here. So if we're just looking between Q1 and Q3, we're looking at that middle half, that middle 50% of our data. So what's important about this is that it measures the middle half of the data. And because of that, unusual values are not even considered. So there are those unusual values, those really high values, the really low values aren't even figured into this measurement. So to calculate the IQR for car gas mileage data set, we have the Q3, which is 31, minus our Q1, which is 26. So our IQR value is 5. The middle half of the cars in the sample only range by 5 miles per gallon, which is really strange because if we look at the range of all of the data, remember we did this up here, we found that the range for all of the data was 30 miles per gallon. So from the highest to the lowest, they're separated by 30 miles per gallon. But if you look at the difference between the middle half, they're only ranging by 5 miles per gallon. So 50% of your data set is only 5 miles per gallon off of each other. So we use the IQR and parts of the 5-number summary to determine if a data set is an outlier or not. So we are going to first check to see if it's too low, if it's too small for our data set. And to do that, we're checking to see if it is less than, For this, we're going to take Q1 minus 1.5 times the IQR value. This will figure in if we have a lower outlier. And we're going to check to see if it has a value that's too high. And that happens if it is more than Q3 plus 1.5 times the IQR value. So it has to be more than that or less than that. If the data point is equal to the value, it is not an outlier. So it has to be less than that or it has to be more than that, but it cannot be equal to that. So we're going to go ahead and make these calculations. As we said, we found that our IQR was 5 miles per gallon. So we're checking our lower outliers. And that again was Q1 minus 1.5 times the IQR. Our Q1 is 26 minus 1.5 times the IQR value, again right here, which is 5. 26 minus 7.5, 18.5. So we look at our data set and we look to see, do I have any miles per gallon that are less than 18.5? And we do. We see that our minimum value was 18. So we find that 18 is lower than 18.5. So it's an outlier. And now we're going to check to see if there are any upper outliers. So we have Q3 plus 1.5 times IQR. So our Q3 value is 31 plus 1.5 times our IQR value of 5. 31 plus 7.5. And the largest our number can be is 38.5. If there's any numbers higher than 38.5, then it's an upper outlier. If we look at our data set, we see that we have 40 and 48 are both outliers because 40 and 48 are both 38.5. So what this does is we show our outliers in the graph. So the one that we graphed originally is actually inaccurate. But I told you leave room above it because we were going to do the correct graph above it to show how your data is actually skewed. So to find the points on the new box plot, we are going to go back up here. In our calculators, we are going to go to second y equals. This is called your stat plot. If I look next to number 1, I see that my stat plot is off. What I'm going to do is I'm going to turn it on. So I'm going to hit enter. I'm going to hit enter to turn it on. And if you look at all the different types of your graphs, we have plotted points, we have lines, we have our bar graph or histogram, box plot, another line graph. So there's 2 different kinds of box plots here. The first one, you see these little dots, that means that this is going to show outliers. That is the one that you want to have. So we arrow over, highlight the box plot with outliers. We hit enter. We had our data listed in list 1, so we're going to keep that where it was. Frequency, you can change any of that other stuff if you want to. And then you are going to hit zoom 9. See how it says zoom stat? And when you hit zoom 9, I had some equations in here. So we're going to go back to Zoom 9. They were giving me an error message. And you can see what we found. We have our lower outlier and we have those two upper outliers. If you hit the trace button, you arrow left and right and you find these values. So we see that our minimum value there is 18. That's an outlier. So what we're going to do is we're going to put a star with that where that outlier was. We arrow over. So now our new endpoint of our box plot is at 23 because that's the next smallest value. Our Q1 is still 26. Our median is still 28. Our Q3 is still 31. So all of that's staying the same. This box isn't changing. But now our new highest value is going to be 34. And then we have an outlier at 40 and an outlier at 48. This is the box plot that shows outliers. When you are doing any problems from here on out, we are not going to show the first box plot. We are only going to show the one with outliers. I wanted to do both of them so that you can see the comparison between a box plot and how the data is actually being skewed by those outlier values. Now, when you turn to the next page, there's quite a few questions, and it's saying if we were to remove the outliers from the data set, how would it affect my numbers? And we kind of saw that already. Our average, I'm just going to tell you, would change to 28.19 miles per gallon. The range, if we saw in our box plot, our smallest value is now 23 and our largest is 34. So our range goes from 30 down to 11 miles per gallon. But our Q1, our median, and then our Q3, we see change very little compared to the original that had all those outliers in it. So that just is basically saying that with the removal of the outliers, both the mean and the range are drastically changed versus the median is only slightly changed, which is going to get into this one, which is the important question, number 7. So how do we know which statistics to use when describing a set of data? We use the mean and the range only if there are no outliers. We use the median and IQR anytime, but especially if there are outliers. Because remember, we showed that the mean and the range are really influenced by those outlier values, whereas the median and the IQR are not. So we can only really use the mean and range accurately if there's no outliers. Mean and median, or median and IQR, we can use anytime, but we especially want to focus on those if the data is skewed. And just as a reminder, which I told you before, when drawing box plots, you only draw the one that shows outliers. If there are outliers, there's not always going to be outliers. You don't draw 2 box plots. You only draw the box plot that does have outliers in it. All right, I know that was a long one today. I'm sorry about that, but we are finished now.